If the universe is so big and life should be common, why haven't we found anyone else out there? One theory says the answer isn't really about aliens at all. It's about a filter. And whether that filter is behind us or still ahead might be the most important question we can ask. This is the Great Filter, one of the most unsettling proposed solutions to the Fermi paradox. Here's what it actually claims: the candidates for what it might be, and a genuinely new twist that's only just been proposed. The idea comes from economist and physicist Robin Hanson, who first proposed it in 1996. Hanson was working at Oxford's Future of Humanity Institute when he framed it as a way to make sense of the silence. The idea builds on an even earlier argument by physicist Brandon Carter, who pointed out that the timing of human evolution, relative to how long the sun will keep burning, already hints that hard steps are involved. If evolving intelligence were easy, we'd expect it to happen much earlier in a planet's habitable lifetime, not cutting it this close. Hanson himself has said he'd actually prefer the filter to be safely behind us. A filter still ahead would mean our own future is far riskier than most people assume. Hanson's argument, somewhere on the road from lifeless chemistry to a galaxy-spanning civilization, there has to be at least one step that's almost impossible to complete. That step is the filter. It doesn't have to be one single event. It could be several smaller barriers stacked together. Researchers sometimes describe this as walking through a series of doors, most of them open, but at least one nearly sealed shut. You only need one of those doors to be nearly impossible for the whole model to work. This channel started with exactly that question. If advanced civilizations are possible, where is everyone? The Great Filter doesn't just ask that question again. It offers an actual answer. Something, somewhere along the line, is stopping almost everyone from making it all the way, which raises the question that makes this whole idea so unsettling. Is that filter already behind us? Or is it still waiting somewhere ahead? If it's behind us, humanity already survived the hardest part, without even realizing it. One strong candidate is abiogenesis itself, the moment lifeless chemistry first became a living, self-replicating cell. As far as we know, that's only happened once, here, in roughly 4 billion years of Earth's history. Another candidate is the jump from simple bacteria-like cells to complex cells with a nucleus, a transition that took over 1 billion years to happen even once. Multicellular life, and eventually intelligence itself, are sometimes listed as additional hard steps already behind us. Some researchers have tried to estimate how many hard steps might be involved, based purely on the timing of major evolutionary transitions on Earth. One influential model suggested somewhere around 4 to 5 major hard steps across life's entire history. Each additional hard step multiplies the odds against any of it happening again elsewhere. This overlaps with a related idea called the rare Earth hypothesis, which argues complex life needs an extremely specific set of coincidences. The right kind of star, a stabilizing moon, plate tectonics, and more. The filter isn't one dramatic event. It's an accumulation of long odds stacked on top of each other. If any of those were the real filter, it means we're already through the hardest part. We might just be rare, not doomed. But there's a much darker version of this idea. What if the filter isn't behind us at all, but still waiting somewhere in our future? Any species advanced enough to be visible across interstellar distances also has to be advanced enough to harness enormous amounts of energy. And that much energy is just as easily turned toward self-destruction as it is toward progress. Nuclear war, engineered pandemics, uncontrolled artificial intelligence, and climate collapse are the most commonly cited candidates for a filter still ahead of us. There's also a version of this tied directly to energy use. Scientists sometimes rank hypothetical civilizations by how much energy they can harness, from an entire planet's worth up to an entire star's, or even an entire galaxy's. The more energy a civilization controls, the more damage a single mistake, or a single bad decision, can do. Some researchers argue that's exactly why we might never see a civilization cross that threshold safely. If that's the real filter, it means every civilization that gets close enough to be noticed eventually destroys itself, including, potentially, us. There's a separate, purely mathematical argument that reaches a similarly unsettling conclusion, just by counting how many humans have ever lived. That idea is big enough to deserve its own explanation, but it points in the same general direction as a filter still ahead of us. In February 2026, researchers proposed something stranger, a filter that doesn't require any disaster at all. The paper modeled population dynamics mathematically, rather than through the usual biological or astronomical lens this topic normally gets. Their idea is called depopulation. As a species becomes intelligent enough to develop medicine and contraception, birth rates tend to fall, sometimes very sharply, Their modeling suggests human population could peak around the middle of this century, followed by a long decline. Their model treats that growth and decline as exponential in both directions, not gradual at all. By that math, human extinction thresholds could realistically be tested sometime after the year 2500, only a few centuries away on a cosmic timescale. Taken far enough, that decline alone, with no war and no catastrophe, could eventually threaten a species with extinction. And there's no obvious reason the exact same pattern wouldn't apply to any other intelligent species in the galaxy. The researchers even extended the idea to artificial intelligence. If machines never become fully conscious on their own, they'd remain tools, and tools stop running once the species that built and maintained them is gone, which would answer a slightly different version of the Fermi question. Why don't we see self-replicating machines colonizing the galaxy either? It's a genuinely new angle in a field that's been circling the same handful of ideas for decades. None of these candidates are confirmed. Nobody knows which filter, if any, is the real one. This isn't just a thought experiment for late-night arguments, either. Philosophers like Nick Bostrom and Toby Ord have built entire careers around studying exactly this kind of existential risk. Ord has estimated the odds of humanity surviving the next century at roughly 1 in 6, treating it almost like a dangerous game of chance. Some researchers argue this should change how we prioritize global problems today, treating civilization-ending risks with the same seriousness as more immediate crises. Others push back, arguing it's impossible to plan around a filter we can't even identify with confidence. Unlike a signal or a structure, you can't point a telescope at the filter itself. This connects directly to why missions like the James Webb Space Telescope spend so much time studying exoplanet atmospheres. Finding a single confirmed biosignature, even from simple microbial life, would completely reshape which filter looks more likely. The only real evidence we'll ever get is indirect, based on whether we keep finding more or fewer signs of life as our searches improve. But the question itself changes how seriously you take humanity's current choices. If the filter is still ahead, then how we handle the next century might matter more than almost anything that's come before it. Every year, astronomers find more potentially habitable planets, and so far, not a single confirmed sign of anyone else on any of them. That silence keeps getting a little more meaningful the longer it continues. Which means this might be one of the rare places in science where simply continuing to search is itself a meaningful strategy. Every year we don't find anyone is, in its own strange way, still real data. So the universe might be silent because life is rare, or because something eventually stops almost everyone. We don't know yet which one is true. Do you think humanity's great filter is behind us, or still ahead? Let me know below, and I'll see you in the next one.